Hi guys, my name is Vladimir Alyamkin and I'm a tech lead at Pushkin Studio, part of My Games. As a studio, we are working on mobile games based on Unreal Engine 4, and most of our development processes are automated with continuous integration and delivery system. As an example, I can mention the asset validation checks, AI-based level tests for QA team, and even game patch build and delivery to production environments. Today, we'll speak about how all of it can be used to make the whole development pipeline efficient and stable, specifically to mobile games development. Okay, let's begin. First, let's speak about continuous integration itself. What is a CI? As Wiki says, it's a development practice, but in real life, we'll speak about a bunch of servers with some specific software installed that doing some tasks trigger it on some conditions. So, technically, it looks like on screens presented. You created some kind of task that grabs your project and then run a build script. The task has success or failure status and produces artifacts as a task result. In a Bamboo, the task is called a build plan and contains subtasks as jobs and steps. Why do we need it? There are a lot of common everyday tasks that could be and should be easily automated. For example, if you want to test a fresh build of your game at target platform, you shouldn't build it manually from the engine. It's better to press the Make a Build button and then get an update on your phone. You can choose the environment to be used, meaning development built with cheats enabled that goes into special Jeff server, or the production one that fully emulates the game as you will ship it. Also, CI systems will handle lots of automatic quality checks, like naming, code style, cooking warning and errors, data model validation, and others. It's hard to overestimate the value of CI system if you are working with a custom Unreal engine. Each time you've made the changes to the engine, you should build and distribute the new version of the engine among the developers and push the changes to all built environments too. The same I can say about building DLLs to keep your team synced. Every single team member should be able just to pull the project from the version control system and run it without compilation. It's easy, it's fast, it's clean. To keep the DLLs at the actual state, all the changes in the main branch should be compiled, checked, and committed, and it's a task that should run regularly. Oh, it should be triggered by event of committing to the selected branch. Okay, sounds nice, so let's use it. As I said before, you need specific software to manage all this stuff. Common examples are Bamboo from Atlassian, TeamCity by JetBrains, and open source one called Jenkins. Sure, there's many more CI solutions on the market, but this one are best for Unreal specific usage. In the world of pure native projects that don't rely on such a huge tech as Unreal Engine 4, you can use container CI to build a project. It's not a deal when we are speaking about Unreal because UA4 requires a custom environment to make a build, including a pre-built engine itself. In this case, you can't just start to use cloud-based CI systems in a push of a button, and else you can't use most of them at all. Okay. But what about the classic one called Docker? Sure, it's still an option. It's widely used and it can be called even a standard for CI usage. Lots of those systems can run custom provided containers with an environment set it up. It's a cloud-friendly approach and in theory it can be easily extended. Sounds good for me. And speaking the truth, Docker is definitely great to distribute dedicated servers. Just pack the servers into a container and run it into the cloud. It's very nice. So why not to use it? Especially if there is a free and proven solution for Unreal Engine on GitHub. Check the link. But we have a bitter pill here, because use of Docker for CI has its flaws. First of all, you need to build and pack the engine inside a container. It's not a trivial task, as environment configuration for UE4 is a bit sophisticated. You can use a third-party solution provided in the previous slide, but then you will rely on it and on its update time to be actual. New versions of Unreal Engine can easily become unsupported at any time, and it's the technical risk you have to take. Second, But very important for us as a mobile games development, you can't use Docker to build an iOS game. So you will need to support the traditional build pipeline anyway. And more parallel approaches, parallel systems means more service to be provided to make it work. More time, more human resources, more bugs, more different situations. Also, containers with V4 inside will be really heavy. Each time you modify the engine, you will need to distribute the results among all physical devices you have. It's not fast as just to pull the changes from the repository and build the engine locally on build agent. So there is no real cloud or on-demand usage here. It's not that case. And the last one, there are lots of limitations with Docker itself, especially on Windows. So if you want to Dockerize your Android client builds, you have to handle these issues. You have to check server health each time it's being updated. And most of all, it's really hard to debug the build process inside a container if something went wrong, and it definitely will. In result, it means that Docker will cover only part of our demands, and it won't be easy to integrate, set up, and support. So it's a kind of the enthusiastic way, and not production one. By the way, I cannot mention the Gauntlet because somehow it's considered as a CI replacement in the community. Gauntlet is not a CI system itself. It's an internal engine framework to run automated tests, and it's a thing that should be triggered and managed by CI for some tasks. Honestly, it's a dream to have a built-in CI system or kind of inside the Unreal. I see it like a shiny and cross-platform with the ability to create different project configurations. File system integration is required too. Also, it should be text one, clear one, and transparent. Personally, I don't really like XML-based script, and please, no. I saw examples, no. And a sacred dream is a cloud-built service like we have in Unity. In an ideal world, I just want to say, okay, Unreal Magic System, please make me a build for my Apple phone and validate it. And it makes it. So it's a dream. It's something I want to see with Unreal Engine. So speaking for now, all the CI tasks and tests require a script or any other kind of a built program to launch the run UAT with pre-configured parameters to make a build and process a build result then. I'm happy to mention VSL here, which is Windows subsystem for Linux, because now we can write an universal build script the shell one and run it on every platform we need. It's a gift. It's cool. Let's return to practical usage examples. CI is a system that can handle lots of non-interesting stuff that will keep your project in a healthy state. For example, you can run tests and check non-ASCII symbols in the file names. Oh, I have to say that Russian S looks totally the same as English C, and it also placed at the same key on the keyboard. It's a nice way to corrupt memory on the iOS. I spent a few days trying to find out why my game crashes. It was a few years ago, and it was hard a bit. Non-Unity builds are important to be sure that you have a consistent structure of header files and include directives in your project. If not, you can meet the situation when a project compiles on one device and fails on another. But it's really not a good idea to work with non-Unity builds locally every time, because non-Unity project compilation will take much more time than Unity one. As an example, in our current development project, it's 3 minutes versus half an hour for full rebuilds on my high-end CPU. So let the robots make it for you every night. It will be okay. Build time can be used as a project health monitor too. Some time ago, I found that full rebuilds of our game models started to be very long and memory demanding. And I should say that we are using lots of templates, so it was not something surprising at all, but definitely not normal compared to previous results. It was a signal for us to act, and we acted accordingly. We found the root of the evil. Core data library was refactored and optimized, and build time was significantly lowered. So it's a good idea to track this time and to check that somehow it's not high. Another interesting example, you can build the PC version of your game and run any client simulation tests you want. It was really useful for us in case of development as session multiplayer mobile shooter with 16 players in a single match. You can see it on the screen, by the way. Stompaloco is turned on, lots of statistic gathering, real client code run, interesting tasks like map possibility and automated draw calls performed. I really recommend to perform that kind of tests, and even if you are making a mobile game, keep the desktop version works the same. It should be the same game, the same project, the same game logic. It's important. By the way, we have a zero warning cooking policy. If there is a warning or error, build won't be successful. It was a hard decision in the middle of the development, but with the power of the CA today, we keep our project clean and shiny. One example I want to point separately. Never, I mean literally, never prepare a game patch without automatization. It needs to be done very carefully. Otherwise, it will be screwed up, and don't be that guy. To build a patch successfully, you need the exact version you have published already, and the new one. Tag them, build them with CI, and deploy. Please, no manual game patching. The last one I want to mention regarding the CI is an integration of Autotest to the whole production flow. We're using a full Atlassian software stack at our studio, and it's definitely great. We settled the up merge requirements, so you can't push anything to the develop branch without a series of auto-test processes on the changes. It really lowers the human factor in production, even with strong code review processes. For today, each feature branch at our project will be processed with a cooking check, data model, integrity validation, automatic code formatting using client format, and a few minor checks, and only then it could be merged into develop. And it's cool that using end-to-end integration of Atlassian services, Jira tasks contain all the history inside, commits, pull requests, build result, etc. It's very organic. And don't miss to configure notification system for CI. React early. If build fails, you need to know who is responsible and should notify them. All plants should be green. Red signs are sorrows, green one are happiness. So keep your bamboo or team city green. Green is good. Okay, just a few numbers for real project. We started to use Bamboo a few years ago working on the Armored Warfare Assault game. It was handled with 7 build agents that did really nice amount of work. Just imagine about 1 million bot battles run and processed to get statistics about the game, maps balance, vehicles behavior, and other stuff. I like these numbers. But let's go further then. As it was mentioned on a previous slide with numbers, we've made more than 4,000 of game builds. It's obvious how to test the build on PC. Just download, unpack, and run. But how to do the same in the world of mobiles? Is it really I need to use a cable or something like ADB to install every new version? Nope. Hope no. Distribution services hurries to the rescue. There are two giants on the market. Firebase by Google and App Center by Microsoft. Both are really great and widely used. I'm sure you've met them if you are working for some kind of corporation. Enterprise builds, accounts, yes. You can say, hey, why not to use native platform solutions? Sure, you can. There is a test flight for iOS applications and Google Play services for Android. You can even wrap them into the Fastlane, a great tool, by the way. But the deal is that they are managed separately. So you need 2 parallel account configurations to run the tests. You will have a lack of analytics on your testing process, and also there is no native crash processing dashboards on both platforms. It's not a joke, in 2020 we still can't process indicate crashes on Android, and on the other hand, TestFlight can give you on symbolicated crashes only, and it's just for the TestFlight app versions. You will get nothing from the released games, so it's a bit strange for me. Regarding distribution processes, for example, I want to share some builds with external contractors. I want to make it fast. I want to have different URLs to install different builds without a headache. And it's not possible with test flights, and it will require review from Apple for each version. That will take time, and also these versions will be in one bucket, and hard to find one you need. Okay, let's just say that distribution process for different groups with different builds is massive for both and Apples, and that's all. So, great. We have solutions that handle this task like a charm, but how to choose? I've pointed out the main differences as they stand for me at the current slide. First, Firebase has the greatest cache handling tool called Cachelytics. It's much easier to use than Breakpad, which is inside the App Center cache model. I almost love Firebase, but surprisingly, there is no internal auto-update notifications to get a new build inside the app. And all I want is to see, hey man, a new version is available. Do you want to install it once the game is launched? But there is nothing. At Firebase, you can have only email notifications about a new build, a new release, but there are no real options to configure them. It's just all or none. On the other hand, App Center has the auto-update feature, but some dirty magic is required to set it up with Unreal. Not cool, and the Breakpad is a tool from hell also. But App Center has one cool feature. You can send uploaded builds directly to the test flight or Google Play. It's very comfortable for me. I have to say that the both services can do nothing with Android expansion files, so it's just for developer taste in case of heavy games on Android. But for iOS and TestFlight, it's very useful to upload builds this way. You need no mark in this case, and Build Agent with any operating system can do it. Your Windows PC can upload builds, a Linux PC can upload builds, so you can use Mac only to build an iOS game, not upload, not process symbols. It's very important in case of how much PC you need to run your CI system. And the final accord, we are using them all. Firebase for caches, App Center to distribute builds among the developers and external testers, and native test flight and Google Play Console for final production build testing, because it's the most native way with all certificate-related stuff applied in-app purchases, etc., etc. I wish there would be a better way to cover all our demands, but as my friend said, mobile game developers should suffer. Few more things. CD is not only about the game client delivery, but managing the servers too. As I said before, it's great to use containers to pack dedicated server artifacts and distribute it to Amazon or DigitalOcean. Server deployment is definitely a task that should be done with robots, and it's also very useful that CI/CD system provides access right control. You can configure who can restart the server and who can't. Different server instances, different rules. For example, QA server, QA access. In result, there is no more manual access key management, no direct access to production server instances. Your CI system plays the role of control panel for your whole game infrastructure spaceship. And speaking about infrastructure, I should mention development stance, as it's part of QA processes. Making a mobile game, you will run lots of tests on hordes of different mobile devices. It takes time even to install the build into all of them, and also to support devices being charged and available. It's a good idea to have a build agent with dozens of mobile devices physically connected, called a development stand. This hero will automatically install the game on demand and run necessary unit tests then, using Gauntlet, for example. Then gather launch logs, analyze it, and upload them as plan artifacts. Surprisingly, the main challenge here is a USB hub that will power this hoard. It's normal at early stages of development that the phone runs out of battery even with DC connected. This hero also should keep all the devices unlocked. Unfortunately, I got no chance to take a photo of our development stand at the office due to virus situation, but you can see a photo of a typical Tristan day, 6 devices and me. So it was the last one, and I want to thank you for watching. I'll be happy to answer your questions, so feel free to ask them.